Fine. Now everyone's attention should be on the screen. We are going to learn how to create a histogram. You must have already learned this in school. Heyman, Rehan, remember learning histogram in school? No. I heard that it is already done in school.
Yes, sir.
Oh, it's already done, no? Yeah. So now, no problem. I'll teach you. Don't worry. Okay. Now pay attention. As we did yesterday, the first thing which we have to draw in a graph is what? The x-axis and the y-axis. Start drawing, children, then we will read what the question is and what we have to plot. Okay. There is nothing much to teach in this. That's why I'm very, casual about it. Yeah. So let us draw the x-axis, y-axis. This is your y-axis, and this is your x-axis. Are we all done? X-axis, y-axis. Please do write it down, okay? The name of the axis. It's compulsory. X-axis and y-axis. All right. Now, pay attention. I'm going to explain how to draw the histogram. Children, the very first thing, class intervals. The class intervals has to be shown on the x-axis. You remember, children, I taught you a general rule yesterday that the class intervals are supposed to be shown always on the x-axis. All right. So, are these class intervals continuous or discontinuous? They are continuous? Yes. So there is no problem or there is no challenge of converting the discontinuous into continuous class interval. Is already given in the continuous format, isn't it? So children, let's start with the class intervals on the x-axis. But here there is a problem. We don't have any idea what's happening from 0 to 10, isn't it? Do we have any idea, children, what is happening from 0 to 10? We have no idea. So what we will do, since we have no idea about it, we will show the class interval 0 to 10 over here. We will show the class interval 0 to 10 over here, just that there is no frequency mentioned for the class interval 0 to 10. We will not bother much about it. You just label the class interval 0 to 10 and just leave it. Okay. The next class interval is what? 10 to 20. After that, 20 to 30. After that, 30 to 40. After that, 40 to 50. And then 50 to 60. Till which class interval we have to go? Oh, all right. Only till 50 to 60, isn't it? Okay. So I'll take one extra, 60 to 70. And you all know what is the reason behind it. In case they ask us to draw the frequency polygon on top of the histogram, we will need one extra class interval, isn't it? If you are not using it, just dump it over there. Okay, don't worry that you had drawn an extra class interval. So what will I do about it? If you're not using it, just leave it like that. Okay, don't bother much about it. Now, let's look out for the frequencies which we have to plot. Children, 3, 5, 6, 4, 2. As I told you yesterday, a knack of finding out how you should divide the y-axis for representing the frequencies. Look out for the highest frequency. 3, 5, 6, 4, 2. Which is the highest frequency? 6 is the highest frequency. So children, accordingly you can label the y-axis for frequencies. Shall I take 1 centimeter is equal to 1 frequency? Just that the histogram will look slightly smaller. Children, you have all the rights or privileges given in order to take each 2 centimeter on the y-axis as what? One frequency. That is also allowed. Why? Because even if you take 2 centimeters as one frequency, 2, 4, 6, 8, 10, 12, isn't it? You have sufficient space on the y-axis to represent all the frequencies given to you in this table. If you don't want to do it, just go with 1 centimeter is equal to 1 frequency. All right. So here I'm going to label it. Each 1 centimeter. This is 1 frequency, 2 frequencies, 3 frequencies, 4 frequencies, 5, and the last one is 6. Okay. And the last one is what?
But
Easy?
sir, y-axis is 10, 20, 30, 40, 50 and like that. And
no
X,
problem, Animesh.
I
No
mean
problem.
x-axis, so it's fine.
No problem. No problem in doing that. No problem. All right. So let us start plotting. Now, children, if you ask me, sir, what is a histogram? Children, yesterday when I started teaching you, what is a frequency polygon? You remember I had given you so much of explanation here. Where it is? I think it up. Not this one, no. Over here. I had drawn one rough diagram before starting. Where is it? After this, I think. This one only. You remember, children? Such a huge explanation I had given you about frequency polygon, right? But in histogram, I don't have to talk much about. Okay, why? If you ask me, sir, what is a histogram? My answer is going to be very simple. Histogram is an arrangement of rectangular bars without leaving any space in between. It just looks like a New York City. Okay. Histogram just looks like a New York City because whenever you see the image of New York City, you see all these skyscrapers adjacent to each other without leaving any space in between, isn't it? And if you want to see a domestic example, you just look around SG Palaya, you go to each and every cross, you will see that every other building is stick to each other, isn't it? Every other building has a common wall. They haven't left even a slight space so that the thieves can go inside the walls and then they can do burglary, isn't it? Not even little space they have left because every other building in SG Palaya is attached to each other. Every other building has got a common wall, isn't it? Technically speaking, we say every other building has got a common wall, right? Histogram is also somewhat similar to it. I think they must have got either inspired from New York City, otherwise from SG Palaya. Okay, just remember this concept. All right, so what is histogram? Technically speaking, is just an arrangement of rectangular bars where no space is left in between each consecutive rectangular bars. Are you getting it, children? This is how we are going to draw the histogram. So this was just an informal definition of histogram. This is not a formal definition, children. It's just an informal definition. Now, once I draw the histogram on this XY plane, you will get a clarity. Why did I express a histogram in this manner? Okay, so what is the frequency for the first class interval? I think it is 3. Isn't it?
3.
The first class interval is what? 10 to 20. The frequency is what? 3. Where is 3? Over here. Isn't it? So children, just highlight this portion and then draw a rectangular bar on this class interval 10 to 20. Just draw a rectangular bar or a rectangular building on top of the class interval 10 to 20. Prove it. Huh? And if you want, children, you can just highlight this rectangular bar like this. If you want. Okay, just to make it a little more attractive, you can highlight the rectangular bar. Easy. Now comes the next class interval, which is 20 to 30. What is the corresponding frequency of 20 to 30? It is 5. So children, 20 to 30 is over here. 20 to 30 is over here. What is its corresponding frequency? It is 5. So children, just highlight this 5 over here. And then draw a rectangular bar or a rectangular building on top of the class interval 20 to 30. Can you all do it? Easy? There is nothing much to explain, children. So easy it is. The next class interval is what? 30 to 40. And what is the class the frequency? 6. So where is 6? 6 is over here. And this is where you have to draw the rectangular bar. Okay. So on top of the class interval 30 to 40, you have constructed another rectangular building. Okay. Just highlight it if you want. The next class interval is what? 40 to 50. And what is the frequency? 4. Isn't it? The frequency is 4. So where is 4? 4 is over here. So let me highlight that portion. Draw a rectangular bar on the class interval 40 to 50. Was that easy for all? The next class interval is what? 50 to 60. And what is its frequency? It's 2. All right. 50 to 60, frequency is 2. Okay, so the building that you're going to construct is very small. Why? Because the frequency is very less. Over here, rectangular bar, and you are done. Children, histogram over. This is all about histogram. The work is done. Okay? Understood, everyone? There was nothing much to explain. Now, children, if you just observe this histogram, don't you feel it is looking like a New York City? All the skyscrapers are attached to each other, having common walls, isn't it? So this is the informal expression of a histogram. Okay. Now, I don't think in school they are going to ask you to draw only histogram. They may ask you to draw a histogram first, and then on top of the histogram, a frequency polygon. Isn't it? That is how they must have taught you in school. Children, I think, yeah, see this? Exactly the same thing which I asked. Construct a combined, children, construct a combined histogram and frequency polygon. Now, what is the meaning of combined histogram and frequency polygon? You have to first draw the histogram and then you have to draw the frequency polygon over it. That means you have to draw both the histogram and the frequency polygon on the very same graph paper. Okay, but when or while correcting papers, I have noticed some students, what they do, you know, they will draw a histogram on a separate graph and a frequency polygon on another graph. That is absolutely wrong, children. When they are asking you to draw a combined histogram and frequency polygon, the examiner is expecting you to draw both the histogram and the frequency polygon on the very same graph paper. Heyman, did it go into your head? Huh? They are expecting you to draw both histogram and frequency polygon on the very same graph paper. After the exam, if anybody comes to me saying that, you know, I did this mistake of drawing both the histogram and frequency polygon on two separate graph papers, you know what I will do. All right. Now, let's draw the frequency polygon also. Yesterday, you remember, children, we learned how to draw the frequency polygon, isn't it? Now here, you don't have to do much of research. You don't have to do much of research because the class intervals have been labeled, the frequencies have been labeled, and every other class interval has shown their corresponding frequencies, isn't it? With the help of rectangular bars. The only thing which you have to do here is you need to find the midpoint of each and every frequency or every class interval. Sorry, not frequency, class interval. Isn't it, children? Do you remember? For each class interval, we used to plot the midpoint. Lima, Anisha, do you remember? Huh? So here, the midpoint, here again the midpoint, 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 and midpoint. All the midpoints are joined. Sorry, all the midpoints are plotted. Now what we will do? We will join these midpoints. Huh, yes?
But we need to take midpoints between 0 and 10 also.
Animesh, please watch yesterday's recording. All your doubts will be cleared.
No, sir, but 0 to 10 we should, right? Because it's in the book also.
Animesh, I have explained everything in the explanatory video yesterday and day before yesterday. All right, I'll send you the link in WhatsApp group also. Just watch it once. Every other point is mentioned there.
Okay, sir.
Okay. Yeah. If I start explaining it, no, it will be a wastage of time.
Okay, sir.
Okay. Yeah. Children, did you all connected? Hello? Did you all connected? Huh?
Yes.
Did you all connect it with a scale and a pencil? Yeah. I am doing it with my free hand because, using a scale is a very tedious job on this pen tablet. Okay. My question to you is the frequency polygon complete? No, it is not yet complete because, we haven't closed the figure, isn't it? And we all know the technique to close the figure. What we will do, we will take the first point or the first frequency, which is over here, and connect it to the midpoint of the previous class interval. What was the initial class interval from where we started our journey? It was 10 to 20, isn't it? So what is the previous class interval to 10 to 20? It is 0 to 10. And where is the midpoint? It's over here. So just connect it to this midpoint. Okay. Now what we will do, Avilash. Understood. Take the last frequency, isn't it, children? Take the last frequency. Avilash, did you mean that? Take the last frequency and connect it to what? The midpoint of the next class interval after 50 to 60. Because in the table which is given to us, we have 50 to 60 as the last class interval, isn't it? So what is the next class interval after 50 to 60? 60 to 70. So we have to connect it to the midpoint of 60 to 70. Your frequency polygon is also done. So this is how you construct a histogram and a frequency polygon together in the same graph paper. Clear, no children? Ronia, is it clear? Yogita, is it clear? Partha? Aaron?
Yes, sir. Clear.
Animesh, today itself you will watch all the previous recordings, okay? Is there in WhatsApp?
So, but this is what I meant. That between 0 to 10 also we need to join the midpoint.
Oh, this is what we meant. Okay. Dikshit, is it clear?
Sir.
Okay. Whether it is morning or evening or night, Dikshit will always have this, what do we say? Chandan, no? A very pious boy you are, man. Very impressed. Okay, next question. Would you like to do this on your own? Huh? Draw frequency polygons for each of the following frequency distribution table using a histogram, without using a histogram. Children, let me tell you something. Nobody is going to ask you to draw a frequency polygon by using a histogram and without using a histogram in the very same question. Okay, because the maximum weightage given will be how much? 4 marks. So 4 marks cannot be distributed for such a big question, where first you are drawing a frequency polygon using a histogram, then you are drawing a frequency polygon without using a histogram. Max to max, what they can ask you is draw a frequency polygon using histogram. That's all. Okay. Either they will ask you to draw a frequency polygon all alone. Otherwise, they will ask you to draw a frequency polygon with the help of a histogram. That's it. Okay. So children, would you like to draw a frequency polygon with the histogram? Yeah. Online students, Mayur, Albi, would you like to draw it? Okay. If you want some support, I can do it for you, children. And those students who are really confident, I know how to do this. They can start drawing the histogram along with the frequency polygon. Okay, those students who need my help, they can look here. First of all, you start with the X and Y axis. Draw the X and Y axis.
Sir, can you just show the question?
Just a minute, Dean.
Sure, sir.
Parents, are you there in the class? Parents, are you there in the class? What then? How many units? You're talking about the y-axis or the x-axis? X-axis. All right. So this is what I said. I will explain it to you. Children, now pay attention. You noticed the class intervals given to us. Some parties going on there. Why everyone is looking there? That's it. Asra. Oh, okay. The first class interval is what? 10 to 30. Then 30 to 50, 50 to 70. Okay. Thank God they are continuous class intervals. Right, boys and girls? They are continuous class intervals because if you see the lower limit of the second class interval and the upper limit of the first class interval, they both are matching. Right? So we can say they are continuous class intervals and their corresponding frequencies are also given to us. Now, children, do we have any idea what is happening for the class interval 0 to 10? Do we have any idea about it? No. Why don't we have an idea about it? Because in the table given to us, they are talking directly from 10 to 30. Isn't it? They have started directly from 10 to 30. They haven't given us any clue about 0 to 10. So, children, even though they don't give us any clue about it, we have to show it on the x-axis. So always start with a 0 and then go till 10. I mean, in this case, till 10. And then after that, you can continue with the class intervals. 10 to 30, 30 to 40, sorry, 30 to 50, right? 30 to 50, 50 to 70, 70 to 90, 90 to 110, and so on. Till where we have to go? 150, right? Okay, fine. Let's go. 110 to 130 and 130 to 150. Plotted. Now comes the second most important part, that is distributing the frequencies on the y-axis. Hemant, tell me how can I decide each centimeter will be equal to how many units? 1 unit. How did you decide that? You have to look out for the highest frequency. 4759564. What is the highest frequency? 10, no. 9, yeah. 9 is the highest frequency, isn't it? So you have enough and more space on the y-axis to accommodate these 9 frequencies or the maximum frequency, which is 9, right? Can we take 1 centimeter is equal to 1 frequency? Hello, children? No, you all have started doing it, no? Online students, I believe you people have started doing. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, I have taken till 11. Then here I will add one extra class interval, which is 150 to 160. Everyone's x-axis and y-axis is ready. Hello, Avilash, Sarah, ready? Ronia, Sean? Oh, you have completed it. Very good. All right. So let's start, children. The first class interval, which is 10 to 30. Advait, are you doing it? Okay, who is it? Pooja, why the camera is off? Good evening, Nana. Partha, Pooja, Terence, keep the cameras on. So the first class interval, 10 to 30, what is the frequency? 4, isn't it? 10 to 30, frequency is 4. All right. So here is your 10 to 30 And the frequency is what? 4. I'll use a different ink, red color. I'll use a green color. So children, this is your 10 to 30 building with a frequency 4. What is the next one? Can somebody help? 30 to 50? 7. All right, 7 is over here. Okay, build the building for 30 to 50. What is the next frequency? 5. All right. So here is your 5. See, we are done with your graph. Okay. Online students, Yogita, Albi, Ananya, done?
Yes, sir.
Yes, sir.
70 to 90. All right. 9 is the frequency. So here we are. Then the next one, 5. The next one is 5. Okay. The next one is 6. Ronia, you're done with the graph. And the last one is? This is not the last one, no? This is the last one? All right. Histogram is ready for all? Okay. Fine, children. Now, shall we draw the frequency polygon also? A very easy job for everyone. Just take the midpoints, children. This is the midpoint. This is the midpoint. This is the midpoint. 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 Okay. Let's connect all the points to each other. 1. Oh, sorry. 1, 2, 3, 4, 5, and 6. Connected. The polygon is not yet complete because we have to connect this point to the first frequency to the midpoint of the previous class interval. This way. And here also. The last frequency to the midpoint of the next class interval. Okay. Job done? All right. Was it easy? Children, just practice 1 or 2 sums at home, and then you don't even have to look behind this chapter. Okay, there's more than enough. Right. Shall we start with mensuration? Area and perimeter. All right. Online students, you have any doubt in histogram, frequency, polygon? I don't think so. It's a very easy chapter. Just do 2 more sums at home and you are ready for the exam. Okay. Fine. So you can keep your graph book inside. Keep your graph book inside and we can start with the next chapter, which is area and perimeter. Two chapters to study. One is mensuration, which is based on 2D shapes or 2-dimensional figures. 2-dimensional figures means triangle, rectangle, square, rhombus, parallelogram, and so on and on. Okay. And the second chapter which we have to learn in mensuration is based on solids. In solids, you will be dealing with cubes, cuboids, cylinders, and so on and so forth. All right. Children, in class 9, usually in most of the schools, they will do the first chapter, which is area and perimeter of 2D shapes properly. But when it comes to 3D solids, cubes and cuboids, they will do only a few selected sums. Only a few selected sums they will do in almost all the schools in Bangalore. All right. But if we have time, we will try to do maximum number of sums from both the chapters. All right. We will try to do. In case, you people get engaged with your preparations for the upcoming exam, then I won't be able to focus much. But children, even after December, I expect to get some more time with you guys to spend based on class 9 syllabus. All right. At that time, I may extend it or I will stretch it for this particular chapter. All right. We will try a level best. Anyways, we are conducting daily extra classes, no? So I believe we can do a lot more sums than expected.
How many topics are left to be done?
What, Animesh?
So for you, how many topics are left to be done?
I don't have an exact. This is the last topic. This is the last one, I think. Probably this is the last one. Rest everything is.
So the rest of the one recorded sessions are there, right?
Rest all recorded sessions are there. You just tell me which chapter you want. Accordingly, I will send it to you in
Okay.
your WhatsApp. Okay. Yeah. All right. So children, we are going to learn area and perimeter of plane figures. So before I start with a plane figure specifically, let me tell you which all plane figures you have to deal with in class 9. Okay, you need to have a clear idea which all plane figures you are going to deal with in class 9. So the first plane figure which you are going to deal with is triangles. The first plane figure which you are going to deal with is triangles. Now, when I say triangles, children, there are 3 or 4 different triangles which you have to deal with in the very same chapter. The first triangle that you're going to deal with is a scalene triangle. If you want, you can just make a hierarchy of all the subtopics which you are going to learn in this chapter. All right, Avilash. The first triangle that you're going to deal with is scalene triangle. The second one you are going to deal with is isosceles triangle. And the third one which you are going to deal with is equilateral triangle. There is one more triangle, children, which is a right angle triangle. Okay. So in fact, there are 4 different triangles that you're going to deal with: scalene, isosceles, equilateral, and right angle triangle. For all the 4 triangles, I'll be teaching you 4 separate formulas. I repeat, for all the 4 triangles, I'll be teaching you 4 separate formulas to find its area as well as perimeter. Okay? Yeah. Then, the next category which you're going to deal with in this chapter is quadrilaterals. What is it, children? Quadrilaterals. In quadrilaterals, which are the subtopics that you're going to learn? The first one is what? Any idea? Yeah, it's going to be a square. The second one is going to be a rectangle. The third one is going to be a square, rectangle, then a rhombus. Hello, children. The third one is what? A
Parallelogram.
The fourth one is a parallelogram. Make a note, children, so that before you start with the chapter, you have a clarity. What all things you will get to learn in this. Okay. After parallelogram, what? Trapezium, isn't it? You will get to learn about trapezium. Children, please do mention here, after trapezium, you will get to learn isosceles trapezium. Isosceles trapezium. Noted it? First, you will learn trapezium, and then as a subtopic, you will learn what? Isosceles trapezium. Then after trapezium, you will be learning about kite. Kite. K-I-T-E, kite. Why you haven't heard kite? They never taught you? I'll teach you. Okay. So these are the subtopics which comes in quadrilaterals. All right. And children, I think after quadrilaterals, you have to learn circles. Did they do this in school? Circles? No? Circle is also a 2D figure, right? They must be doing it. Now, if you ask me, in circles, which are the different type of circles that you're going to learn? Please don't ask that question, okay? In circles, you will be learning only about circles. Okay, there is no different type of circles like isosceles circle or scalene circle, equilateral circle. There is no concept like that. In the topic circles, you will be learning only about circles. Avilash, what did I say now? Steve, what did I say now? Only one circle. Yeah. Noted it? Everyone, Mayur, Yogita, Nana, did you all note it down? Okay, fine. So shall we start triangles? Let's start with triangles. Avilash, what was the first triangle which I wrote in the previous page? Okay. Scalene triangle. Scalene triangle. All right. Yogita, keep the camera on. Joshua, Aaron, Dikshit, Debbie, did you all note it down? All the subsections that we are going to learn? Huh? Advait, Ananya, you all have noted it, no? Animesh. Okay. The first triangle, children, which is a scalene triangle. Now, you all are in class 9, so you must be knowing. Ronia, what is a scalene triangle? Wait, your name is Ronia? You look here. What is a scalene triangle? Two sides are equal. Excellent. Yogita, can you tell me what is a scalene triangle?
Sir, all the sides are not equal.
Exactly. Ronia, what did Yogita answer? Listen. What did she say? What did Yogita say? All sides are. All right. Now silence. Okay. Children. Now what is a scalene triangle? Let me give you a demonstration. Ronia, one, I'll give you now. Keep quiet. Triangle A, B, C. Did you notice, children, I have drawn a triangle here which has got all the three sides different in measurement, isn't it? So if I want to give the actual measurement to all the three sides, I cannot use a scale and measure it over here. So I'll just randomly give some values. Let me take AB is equal to 6 centimeter, BC is equal to 12 centimeter, and let me take AC is equal to what? 16 centimeter. All right. Is there any problem? No problem, right? Yeah. So these kind of triangles, children, these kind of triangles whose all the three sides are different in measurement, they are known as what? Scalene triangles. Okay? These kind of triangles whose all the three sides are unequal or different, they are known as scalene triangle. Now, if I ask you how to find the area of a scalene triangle, how to find the area of a scalene triangle when all the three sides are given to you? Just a minute, huh? Children, I will draw one more scalene triangle over here. Okay. I'll draw one more scalene triangle over here. Say, for example, it is triangle APQR. Imagine PQR is a scalene triangle. Okay. I'm telling you, side PQ is equal to small letter A, QR is equal to small letter B, and PR is equal to small letter C. Now, what does this A, B, and C represent? It represents the length of all the three sides of the triangle PQR. So the length of PQ is A centimeter or A units. The length of QR is B units, and the length of PR is what? C units. In this case, if I ask somebody to find the area of the scalene triangle, how will I find it? This is the question. So children, we have a formula called exactly Heron's formula in mensuration. We have a formula called Heron's formula in mensuration, which will help us to find the area of a scalene triangle. Can you please make a note of this? In mensuration, we have a formula called the Heron's formula, which will help us to find the area of a scalene triangle when all of its three sides are given to us. I'll teach you what is Heron's formula, and then we will solve a sum based on it. Okay, noted it? Heron's formula to find area of a scalene triangle. Now, what is the formula? The formula is area is equal to square root of S into S minus A into S minus B into S minus C. Make a note of this. Make a note of this. What is Heron's formula to find the area of a triangle? It is square root of S into S minus A into S minus B into S minus C. Now you all are very anxious to know what is S. You all know what is A, B, and C, isn't it? A, B, and C are the three sides of the scalene triangle. But you all are anxious to know what is S. Children, yes, Rehan? Exactly. And what is the full form of S? Semi-perimeter. Children, kindly note it down. What does S stands for? S stands for semi-perimeter. Now, what is the meaning of semi-perimeter? The half of perimeter. All right. So, children, if you want to get the value of S, that is semi-perimeter, you just need to take the sum of all the three sides and divide it by what? 2. Why? Because you just need to take the half of its perimeter. How do you usually find the perimeter of a triangle? By taking the sum of all the three sides, isn't it? By taking the sum of all the three sides, you get the perimeter. So, perimeter is A plus B plus C. Now, semi-perimeter will be what? The half of the perimeter. How will you find the semi-perimeter in that case? A plus B plus C whole divided by 2. Okay, so this is semi-perimeter. And A, B, and C, you know. What are A, B, and C's? They are the sides of the scalene triangle. Okay, they are the sides of the scalene triangle. Everyone has noted the formula. Now let us start solving a sum. Okay, let me take the first question. Here it is. All right. They are asking us to find the area of a triangle whose sides are 18, 24, and 30 centimeters. Children, they are asking us to find the area of a triangle whose sides are 18, 24, and 30 centimeters. And also find the length of altitude corresponding to the largest side of the triangle. Children, please don't think about the second part of the sum. That will take some time for me to teach you. All right. First of all, let us focus on the first part, finding the area of a triangle whose sides are 18, 24, and 30. So if I ask you what type of a triangle it is a scalene triangle. Why? Because all the three sides are equal in measurement, right? So A, B, C. Side AB I'm assuming as 18 centimeters. Side BC I'm assuming as 24 centimeter. And side AC as what? 30 centimeters. All right. Very good, Albi. Yogita, I'll check the message later. Huh? Now, they are asking us to find what? The area. Children, shall I do one thing? I will take the value of small letter A as 18, small letter B as 24, and small letter C as 30. I hope there is no problem in doing this. We needed to denote A, B, and C, isn't it? So A is 18, B is 24, C is 30. You can randomly take the values of ABC, children. There is no compulsion that you have to take A is equal to 18. You could have taken A is equal to 24 also. That is your wish. Okay. Now, if I ask you, what would be the semi-perimeter of this triangle? What would be your answer? A plus B plus C whole divided by 2. So we already know what the values of A, B, and C are. It is 18 plus 24 plus 30 whole divided by 2. How much is 18 plus 24 plus 30? 72. Oh my God. Is it? 48 plus 24. Yeah. It is 72. And 72 divided by 2 is 36 centimeters. Very good. So you got the semi-perimeter as 36 centimeters. Now, we all know how to get the area of a scalene triangle by using Heron's formula, isn't it? Laura, can you tell me what is Heron's formula? S into S minus A, S minus B into S minus C. Very good. Now this is equal to, let's start substituting the values into it. You get up and take it, man. Get up and take it. Yeah. Let's substitute the values into it. Online students, start doing it. S is what? 36 into S minus A. That is 36 minus 18 into S minus B, which is 36 minus 24 into S minus C. That is 36 minus 30. Okay. 36 minus 30. Now this is equal to square root of 36 into, let's simplify it. How much is 36 minus 18, children? 36 minus 18, how much it is? 18 itself into 36 minus 24 is how much? It is 8. Oh, sorry, 36 minus 24 is 12 into, what is 36 minus 30? It is 6. Rehan, are you doing it? Okay. Now, children, please pay attention here. Even if you have solved it or if you know how to solve it, still you will listen to what I'm teaching here. A very crucial point where most of the students will waste their time during the exam. You know, this is a very crucial point. What usually children does is they will multiply all the 4 numbers, 36 into 18 into 12 into 6, and hence they will get a very big number, maybe a 3 or a 4-digit number. Wait, just a minute, just a minute. You may get a very big number, and then you will use the long division method, or you will use the prime factorization method to find the square root of that big number, isn't it? But children, I will never suggest you to go with that method. You know what is the reason behind it? It's highly time consuming. Okay, so what is the alternative method, Sarah? Tonya, what did I teach you till now? What did I say? No, what did I tell you not to do? What was it? Tonya, go and stand in that corner. Before I teach, a couple of times I told you have to pay attention here because I'm going to discuss a very crucial point. And when I ask you some questions, you have no answer. Where is it? Same method? Then it's okay. Fine. Listen. Now, children, listen. So what you have to do is take each and every number. Take each and every number and start prime factorizing it. Okay? Start prime factorizing it. How will you prime factorize it, Ronia? All right. Now, let me tell you a fact. Okay? 36 is 16 to 6. Very good. Children, I'll tell you something. When I ask you to do prime factorization of 36, this is the usual step which you follow. 2 into 18, 2 into 9, 3 into 3, and then 3 into 1. This is what you usually do, isn't it? It's absolutely correct, children. I won't deny that it is wrong. Sorry, it is correct. It is absolutely correct. But still, you know, I will not recommend you to go with such a long prime factorization. You know what is the reason? You know that the number 36, this is a very special case. I repeat, this is a very special case where 36 is what? It's a perfect square. Do you agree with that? 36 is a perfect square. So rather than doing the prime factorization of 36, why can't you directly write it as 6 into 6? Will there be any problem with this? There won't be any problem with this. If you write 36 as 6 into 6, just because 36 is a perfect square. Okay, so 36 is 6 into 6. Now, what about 18? Children, can I apply the same rule for 18 also? No, I cannot apply the same rule for 18. Why? Because 18 is not a perfect square. I repeat, 18 is not a perfect square. So how will you start prime factorizing it? 2 into 9, 3 into 3, and 3 into 1. So let me write this 18 as 2 into 3 into 3. Easy. The next number is what? 12. Huh? These two numbers are done. The next number is what? 12. 6 3 is 18. That is also accepted. No problem with that. Okay. Prime factor.
You can't take directly 9 instead of
Directly, what should I take?
like 9 instead of 2.
9 instead of? Devaditya, don't go with too much of shortcuts also. Okay, you will fall into trouble. Fine. Yeah. What is the prime factorization of 12? It is 2. Is 12 a perfect square? No, 12 is not a perfect square. So 2 into 6, 2 into 3, and 3 into 1. So let me write it here. 12 as 2 into 3. Okay. The last number is what? 6. So shall I write it as 2 into 3? Yes. So I have written 6 as what? 2 into 3. Prime factorization of all the numbers are done? Yes. All the numbers are done. Now, how will you find the square root? Sonia, you followed the same method? You knew that I'm going to teach you this? Oh. Just okay. Fine. Now, children, what we have to do? We have to eliminate the square root sign. And how elimination of square root sign is possible? Just by taking the pair of equal numbers. Isn't it? The pair of equal numbers. So the first pair is what? 6 and 6. So that will come out as what? 1 times 6. Then this 2 and this 2. That will come out as what? 1 times 2. Then one pair of 3 will come out as 1 times 3. Then this 2 and this 2. That will come out as what? 1 times 2. Then again, children, these two 3's will come out as what? 1 times 3. This would be easy when compared to multiplying all the numbers together and then finding the square root. Okay, this is an easy method. Let's find the product. 6 into 2 is 12. 12 into 3 is 36. 36 into 2 is 72. 72 into 3 is how much? 216. Is over, no? 216 centimeters square. The root is already eliminated, no, Rehan?
Yes, sir.
Is already eliminated. So everyone got 216. That's right. Got. Sonia, how much you got? 216. Here also Pooja, Animesh, Aaron, Albi, very good. 216 centimeters square. Okay. Now, the next part of the question. They are asking us to find the length of the altitude corresponding to the largest side of the triangle. Okay, so what I'll do is, I will draw this triangle once again. What were the measurements? I forgot. What were the measurements? 18, 24, and 30. What they have asked? They have asked us to find the length of the altitude. You know what is the meaning of altitude? It is height. Okay, please make a note of this in your question itself. Altitude means what? Height. What is the other name given to height? It is perpendicular. Do you remember, children? Huh? Perpendicular, altitude, height, all these are what? Same thing. Okay, perpendicular, altitude, and height. All the three words mean the same thing. So they are asking you to find what the height of the triangle. Now, children, they have given us a particular condition. What is the condition? The height which you're going to find should be corresponding to the largest side of the triangle. The height which you're going to find should be corresponding to the largest side of the triangle. So before I teach you how to solve this sum, let me explain an important fact over here. Okay. Imagine you have a triangle ABC. I'm not mentioning what type of a triangle it is. It can be a scalene, it can be an isosceles or an equilateral triangle. Okay. I don't know what kind of a triangle it is. Always remember, children, for any given triangle in this world, there will exist three different altitudes. There will exist three different altitudes. Altitudes or heights or perpendiculars. Okay, can you please make a note of this? For any given triangle in this world, there will exist three altitudes. Noted it? This side, Laura, Ayan, noted. Online students noted it. Three different altitudes. Now you are again, a little anxious to know how come one triangle can have three different altitudes. For that, you need to understand one important keyword, children. One important keyword. Okay, the keyword is corresponding height. Or simply speaking, corresponding altitude. Okay, you need to know what is the meaning of this term, corresponding altitude. Okay, there is a lot of significance to this word corresponding, because most of the children don't understand why do we use the word corresponding. Okay, unless you don't know why or what is the significance of the word corresponding, even if you get full marks in maths, I'm telling you, you're technically not sound. Okay, that is why I'm giving you so much of stress on this word, corresponding altitude. Imagine, children, okay? Just imagine that I am considering side BC. I am considering side BC. We have how many sides in a triangle? Three sides. Here in this case, AB, BC, and AC. There are three sides in a triangle, out of which I am considering side BC. Okay? This side BC will have a corresponding altitude. You know what does that mean? It means, what is the opposite vertex of BC? What is the opposite vertex or opposite angle to BC? It is A, isn't it? When I say corresponding altitude to BC, it means from this opposite vertex A, I draw a 90-degree line. This red colored line which I have drawn, which is making 90-degree angle with BC, that is known as what? The corresponding altitude of BC. Okay, imagine, children, I'm plotting this point as E. Okay, I'm plotting this point as E. Wherever that red colored line comes and falls on that BC, that point is taken as what? E. So the red colored line segment which you can see here, AE, that happens to be what? The corresponding height of BC. Okay, that happens to be the corresponding height of BC. Now, children, I will write here AE is the corresponding height of BC. So you must be thinking, in that case, do we have corresponding height of AB or do we have corresponding height of AC? My answer is yes. We have corresponding height for AB as well as AC. How will I draw it? Children, this is how I'm going to draw the corresponding height of AB. Which is the opposite vertex of AB? C. So from this opposite vertex C, if I draw a 90-degree line, from this opposite vertex. So see, if I draw a 90-degree line, imagine this point is F. Then CF becomes the corresponding altitude or height of AB. Are you getting it, children? Huh? So do we have a corresponding height of AC? Yes, we have a corresponding height of AC. And how we will draw it? We will take the vertex opposite to AC. From the opposite vertex B, I will draw a 90-degree line. From this opposite vertex B, I will draw a 90-degree line to AC. Say, for example, this point is G. Then DG becomes the corresponding altitude or corresponding height of AC. Are you getting it, children? So whenever they use this word corresponding, don't underestimate it. Don't think that they have simply given that word. It does have a lot of meaning. Okay, children, if I tell you that the side BC is equal to 12 centimeter and the perpendicular BG is equal to 8 centimeters. Now look at the figure and tell me, can this BG be considered as the corresponding height of BC? Can this BG be considered as the corresponding height of BC? No. Lima, it can be? No, isn't it? Huh? Because where is BC? BC is over here, isn't it? And BG is what? Over here. BG is the corresponding height of which side? It is the corresponding side of AC and not the BC. Okay. Did I explain it better? Clear, everyone? So children, this is the significance of using the word corresponding. All right. Now I will get back to the question and solve it. They were asking us to find what? The corresponding height. The length of the altitude means the height. The length of altitude corresponds to the largest side of the triangle. So if you want to frame this sentence in a simpler way, you just need to find the corresponding altitude of the longest side. That's all, children. They could have framed the sentence in such a short manner. Okay, there is no need to write find the length of altitude corresponding to the largest side. Simply mention find the corresponding altitude to the longest side. That's all, isn't it? Now, children, I am going to the diagram. You tell me out of 18, 24, and 30, which is the longest side? 30. So I have considered AC as the longest side. Yes, I have considered AC as the longest side. So if they are asking us to find what is the corresponding height to side AC, don't you feel that will be the perpendicular drawn from opposite vertex B to this side AC? Yes. So imagine, children, BD is the perpendicular drawn from the opposite vertex B to side AC. So what we need to find here? BD. Understood, children? What we need to find here? BD. BD is the corresponding height to side AC. Why? Because AC was the longest side. Okay? Any doubt, children? Please unmute and ask. Mayur, Ananya, Animesh, Partha, Yogita, Naina. No doubt? So far, I'm very clear. No doubt. Joshua, Dane?
No, no.
Parents,
No, sir.
Alpay, Pooja. Pooja, Vani, your cameras are off right from the beginning. Very good, Animesh. Pooja, why your camera is off? Okay, so we have to find what? BD. Now, we will find the value of BD. Let me go back to this page once again. Children, you are given a triangle like this. Okay, you are given a triangle like this. Say, for example, ABC. Children, whether you use Heron's formula or you use any other basic formula like 1/2 into base into height, the area which you get, the area which you should get, that should be the same, no? Will the area of the triangle change? No. Isn't it? You take any three sides of the triangle, you take all the three sides of the triangle and you apply it into Heron's formula, you will get an area. Suppose I was using 1/2 into base into height and I was finding the area of this triangle. Still, I would have got the same answer. Do you agree with that? Huh? Children, always remember, for a particular triangle, I repeat, for a particular triangle, no matter whichever formula you use, or no matter whichever base and corresponding height you use, the area of the triangle or the perimeter of the triangle always remains the same. Are you getting it, children? It always remains the same. Imagine, Steve, you will not pick that pen. Yeah. You will not pick that pen, I said. Yeah. Now, children, listen. Imagine you bought a Kaju Barfi. From your nearest bakery, you bought one Kaju Barfi. Okay. Or Mad Angles. You all know what is Mad Angles, no? Yeah. Those chips. Children, you look at, you try to figure out the area of that Kaju Barfi from this angle, or from this angle, or from this angle. Will the area of that Kaju Barfi change? No. Isn't it? From whichever side or corresponding height you take the area of that Kaju Barfi, the area is not going to change. Unless somebody comes and snatches it away by breaking it into two parts, the area will get divided. Isn't it? Otherwise, the area will remain the same. So children, the same logic we have to apply here. The same logic we have to apply here. Remember one thing. Whenever a triangle is given to you, for that given triangle, if you are assuming BC as its base, okay, for a given triangle ABC, you are assuming BC as its base. You all know what is base, no? Children, you know what a base of a triangle is? The side of the triangle with the help of which it sits on the floor. That is known as what? The base of the triangle. So this triangle ABC is sitting, isn't it? So children, it is sitting with the help of which side? BC. So I'm assuming BC as the base of the triangle. Okay. If I ask you to draw the corresponding height of this triangle, how will you draw? From the opposite vertex A, I will draw a perpendicular line to side BC, isn't it? Imagine that line segment is AD. Then what is AD? AD is the corresponding height of the base BC. Children, I'll ask you a very basic question which you have already utilized in class 7 and 8. What is the formula to find area of a triangle whose base and height is given to you? Half into base
Half
into
into
height.
B into S.
Exactly, Mayur. 1/2 into base into height. You all remember this formula? Because when you started learning triangles in class 7, this was the first formula which your teacher had taught you. When the base and its corresponding height is given to you, then the area of the triangle is 1/2 into base into height. Isn't it? Now, children, here in this case, okay, in this case, they have asked you to find what is the corresponding height of side AC, which is the largest side, isn't it? I'll do one thing, children. I will just flip this triangle slightly. I will make AC as the base of the triangle, okay? I will just make AC as the base of the triangle. So how much was AC? 30 centimeter. How much was AB? Oh, just a minute. Just a minute. Huh? Just a minute. I'll make that change over here. This is A and this is C. All right. AC is how much? 30. Then AB is how much? 18. And CB is how much? 24. All right. Now you must be thinking why I made this modification. Just to make you realize that AC can be considered as the base of the triangle. I just flipped the triangle, children, so that the triangle is sitting on side AC. And you can consider AC as the base. Okay. So shall I write it here? AC is the base. Now, you have to find what the corresponding height of this triangle. So let me assume BD is the corresponding height of the triangle. All right. And we have to find what? BD here. Okay. Children, whether for a given particular triangle, you find the area by using a Heron's formula or by using 1/2 into base into height. The area will change? No, the area will never change. How much was the area, children? How much was the area of this triangle? It was 216 centimeters square. Do you all agree with that? You had found no 216 centimeters square. So children, area is equal to 1/2 into base into height. Okay, how much is the area? 216, which is equal to 1/2 into. What is the base here? For this particular scenario, what is the base here? Ronia, 30. And h is the corresponding height of the base AC. All right. Can I frame this equation, children? This is my question to you. Can I frame this equation? Yes, I can frame this equation. Why? Because the area was already found in the first part of the question. How much it was? 216. So 216 is equal to what? 1/2 into the base, which is 30 in this situation, and its corresponding height is what? H. Now, if I simplify this, won't I get the answer? Yes. So children, 216 is equal to what is left? 15 into H. So this implies H is equal to 216 divided by 15. Isn't it? 216 divided by 15. If you divide these two numbers, whatever answer you get, that is the corresponding height of AC. That is the corresponding height of AC. 14.4 is the answer. Many of the students have answered it. Nana, how much you are getting? Same answer. 14.4. Was it easy to understand? And children, the logic is clear for all. No matter whichever formula you use or from whichever angle you view the triangle, the area will never change. Okay, fine. You need a break? 5 minutes? All right. Online students also drink some water and come back, okay? 5 minutes. Yeah. So what they have said, the length of the sides of a triangle are in the ratio 3:4:5. This is a ratio based sum, children. Very good, Animesh. This is a ratio based sum. So if you want to understand the sum very clearly, children, I will draw a figure for you. Okay. Triangle A, B, C. Have they mentioned what type of a triangle is this? They haven't mentioned what type of a triangle is this, but they have mentioned that the length of the sides of this triangle are in the ratio 3:4:5. Isn't it? Children, this sum can be solved in two different ways. Okay, very in advance, I am telling you that this sum can be solved in two different ways. One is a very long method where you will be applying the concept of Heron's formula, or where you will be applying Heron's formula. The other one is, I don't know whether you remember this. I have taught you Pythagoras theorem. You remember? This year itself, I had taught you Pythagoras theorem. You remember the concept of Pythagorean triplets? Pythagorean triplets, children. See this? For a given right angle triangle, if the height happens to be 3 units, the base happens to be 4 units, then the hypotenuse will be equal to how much? 5 units. And children, in class 8, you had Pythagoras theorem, where very specifically your teacher must have told you that the numbers 3, 4, and 5 are what? Pythagorean triplets. Do you remember this? Pythagorean triplets. Okay. Now, coming back to the initial point, I told you that this particular sum can be solved in two different ways. One is by applying Heron's formula. The other one is, and the other or the second one, which is very short in method, is by applying the concept of Pythagorean triplets. All right. Now it totally depends on you. How do you perceive it? Okay. I will teach you both the ways. Yes. And that's what I said. Heron's formula, semi-perimeter. Wait. I'll teach. Just a minute. Okay, children, find the area of the triangle if its perimeter is equal to what? 144 centimeter. All right. I'm telling you both the possibilities. Steve, both the possibilities. Out of these two, whichever method is comfortable for you, you go with that. Okay, that's what I'm saying. All right. Now, children, I will personally recommend you to apply the concept of Pythagoras theorem. Okay, it's a personal recommendation. Now you can decide which method you want to select. All right. Here, children, they have told you that the length of all the three sides of the triangle are in the ratio 3:4:5. Do you remember in class 7 when you were doing the chapter ratios? In class 7, you had this chapter ratio. Huh? When you were learning that chapter ratio, your teacher must have taught you this. Whenever three sides or three quantities are taken in ratio form, you can always take a common factor for all the three values. Say, for example, x. Do you remember, children, your teacher telling you this? Huh? For all the given three sides or three quantities, which is in fact given in the ratio form 3:4:5, you can take a common factor x amongst all the three values. Huh? So children, if you want to actually write down what would be the length of side AB, you can write it as what? 3x. If you want to write the length of BC, you can write it as what? 4x. If you want to write the value of AC, you can write it as what? 5x. We are taking a common factor x in between all the three values given to us in the ratio form. How many of you remember this? Please raise your hand. Offline. Lima, you don't remember? Anisha? No? Asra? Laura? Don't remember taking a common factor? Huh? Okay, here also online students also remember. Partha, Mayur, Yogita, you all remember taking a common factor? No. Dikshit, Animesh, Joshua, remember? Or should I teach you again? Aaron, Partha, Abby, Terence, Pooja, Vani, Advait. Should I teach you again? Or you know how to do it?
Yes, sir. No need, sir.
No, you should be taking a variable x. Don't take one. Okay. Now, children, now listen. So this is how we take a common factor in between all the three values. Now what? So children, what I'm doing here, I am assuming the length of AB is what? 3x. The length of BC is what? 4x. And the length of AC is what? 5x. I'm just assuming it. That is not the actual length, but I'm assuming that the length of AB, BC, and AC are 3x, 4x, and 5x. Children, they have told you that the perimeter of this triangle is what? 144. What is the concept of perimeter? The sum of all the three sides of the triangle, isn't it? Huh? So if I take the sum of 3x, 4x, and 5x, that would give you how much? 144. Now, what is the sum of 3x, 4x, and 5x? 12x. And that is equal to how much? 144. In that case, can't I get the value of x, children? I can get the value of x. 144 divided by 12. How much it is? It is 12. Okay. I'm getting x is equal to what? 12 itself. So what did I find here? The common factor which exists. Children, the common factor which exists in between all the three sides, AB, BC, and AC is what? 12. All right. Now, can't I find the values of AB, BC, and AC individually? Yes. How much was AB? 3 times x. So x value is what? 12. 3 into 12 will be how much? 36 centimeter. So I was able to find what? The actual length of side AB, which is 36 centimeter. Now, the length of BC is what? 4x. So 4 into 12, that is equal to 48 centimeters. Okay. Hemant, is it clear? And AC is what? AC is 5 times x. And what is 5 into 12? It is 60 centimeters. You got all the three sides of the triangle? Yes. Now, children, once you get all the three sides of the triangle, you can figure out what kind of a triangle it is. All the three sides are different in length, 36, 48, and 60, isn't it? So it is a scalene triangle. The moment you realize that it is a scalene triangle, you will think of applying which formula? Heron's formula, isn't it? Not Heron's formula, Heron's formula. All right. You can apply Heron's formula to find the area. Now, children, I will ask you to apply Heron's formula and find the area, not now, but at home. So this is the homework. First time I'm giving you one sum to do as homework, which is this. By applying Heron's formula, you have to find the area of the triangle. But before that, before winding up the session, let me ask you one thing, children. Let me ask you this. You knew that the ratio between all the three sides of the triangle was 3:4:5, isn't it? That was the ratio between all the three sides, 3:4:5. And you also know that these three numbers, 3, 4, and 5, are Pythagorean triplets. The numbers 3, 4, and 5 are what? Pythagorean triplets. So children, if they are Pythagorean triplets, don't you feel triangle ABC would be a right angle triangle? Don't you feel so? Triangle ABC would be a right angle triangle. Children, the moment you're getting three numbers which are Pythagorean triplets, indirectly, you're getting an idea that the triangle should be a right angle triangle, isn't it? So can't I consider the height of the triangle as 3 times x, the base of the triangle as how much? 4 times x, and the longest side in the right angle triangle is what? 5 times x. Can't I assume this? I can assume this. Huh? That is just because I got the Pythagorean triplets. If these three numbers were not Pythagorean triplets, then I am left with only one method, and that is Heron's formula. Okay, this is a very special case where the numbers happen to be Pythagorean triplets, and hence I am able to apply the concept of right angle triangle. All right, children, can you tell me how much was the length of BC, the actual length? I think it was 48 centimeter. How much was the length of AB? 36 centimeter. Now you observe this diagram and the labelings and tell me, if I want to find the area of this triangle, can't I use the formula 1/2 into base into its corresponding height? I can use the formula, isn't it? What would be the base, Ronia? In this case, what would be the base of the triangle? Hemant, Rehan, 5. It is base ഏതാടി എവിടെ triangle ഇരിക്കുന്നേ 48 BC, isn't it? Yeah. So 1/2 into base is what? 48. What is this corresponding height? 36. Children, just do this and you will get the same answer which is given in the textbook. I bet on you. 2 ones are 2 into 24s are. So how much is 24 into 36? Just find this.
864.
864. Very good. So 864. Is it given in the textbook? 864? Yes. 864 centimeters square is the answer. Now I want you all to get me the same answer when you come tomorrow. When you come tomorrow, I want you all to come with the same answer by applying which formula? Heron's formula. Okay, this is the homework for the day. Online students, I want you all to do the homework and send me a pic in WhatsApp personal window. All right?
Yes.
Animesh, Yogita, Ananya, everyone. Nana, Aaron, Joshua, Dikshit.
Yes, sir.
All right? Advait, Pooja, Vani. Did
Yes,
I ask
sir.
you to stand? Huh? Stand up. അത് പിന്നെ എടുത്താൽ മതി. ഇരിക്കട്ടെ അവിടെ. Fine. Children, two more. I'm talking. Am I doing Bharatanatyam over here? Listen to what I'm saying. The class is not yet over.